Hey everybody, we're going to do a series of 3 videos that enables us to work on the handout that you see on the screen here, compounds and metals and nonmetals. So what we're doing is we're taking all the periodic table trends and the different types of information that are available on the periodic table and using it to kind of synthesize and put together an understanding of how ionic compounds form. So this particular handout has 3 sets of descriptions, one on potassium bromide, and then one on calcium oxide, and one on sodium chloride. So we're just going to do, for this video, the one for potassium bromide, and then we'll do 2 other videos for the other 2. Okay? So when we look at potassium and bromine here, specifically potassium to start with, you notice that potassium, it says potassium has 1 weakly held valence electron far from a core charge of positive 1. So how do we know it has 1 electron? Well, when we go to the periodic table, you'll notice that it's in group 1. So because it's in group 1, right, 1A, we know that it has 1 valence electron and it has a core charge of positive 1. Okay, so when you go back to the diagram, you can see here there's its 1 valence electron and its core charge of positive 1. How do we know it's weakly held? Well, the fact that potassium is on the left-hand side means it's quite a large atom. As you move from left to right across a period on the periodic table, atoms are getting smaller. And so potassium is quite a large atom, plus it's down in period number 4. And atoms get larger as we move down a group. So potassium is quite a large atom, and you can see that in the drawing that's here. And because of that, its low core charge and its large size makes it poorly electronegative. So it's not very good at stealing electrons. It's not very good at holding its own electrons. And it's far from a core charge of positive 1. Again, that's based on the size of the atom. Bromine, however, has 7 strongly held valence electrons, very close to a core charge of positive 7. It has room for 1 more valence electron. Okay, so how do we know it has 7 valence electrons and a core charge of positive 7? So when you look at the periodic table, bromine's over here on the right hand side. It's in group 7A. So that means it has 7 valence electrons and a positive 7 core charge. How do we know that they're strongly held? Well, the fact that bromine's over here on the right hand side indicates that it's a very small atom. That plus its very large core charge of positive 7 makes it very electronegative. It's quite strong. And we know that as you move up and to the right on the periodic table, electronegativity is increasing. So that gives bromine the ability to hold its electrons quite strongly. And it has room for 1 more valence electron. We know that's true because the maximum number of electrons that are in bromine's last shell is 8. Well, if it has 7 valence electrons, it has room for 1 more. Okay, and all that is reflected in the diagrams. You can see potassium's larger than bromine. We can see potassium has positive 1 core charge and 1 valence electron. Bromine has 7 valence electrons and a core charge of positive 7, and it's smaller. So all that reflects the periodic table trends on the periodic table and the position of potassium and bromine with respect to each other. Potassium's valence electron is much more strongly attracted to bromine's core. You can see that with the arrows here. How do we know that's true? Again, bromine, because it's a smaller atom, has a greater core charge. It's more electronegative. It's going to pull quite strongly on this electron here that potassium has. So bromine steals the electrons. Potassium ends up becoming a positive 1 cation because it has 1 less electron, 1 less negative charge. Bromine ends up being a negative 1 anion because it stole that 1 electron from potassium. It has 1 extra electron. And so again, we see that in the description here, but also in the diagram. Now, when you get a whole bunch of potassium and bromines all doing the same thing, then we get that nice crystal lattice arrangement forming. So it says here the ions are attracted to each other in a crystal lattice. And notice, the potassium ion, positive 1 cation, has anions around it, and then the bromide anion has potassium ions around. So they all arrange themselves like this to maximize the attraction to ions of the opposite charge, and we call that a crystal lattice. Okay, So we'll see you in the next 2 videos, and hopefully you can use these ideas in this first example to kind of structure your answers for the next 2.